Please, you can call the attention of your colleague on the WhatsApp group to join us. Let them know that the class has started. Okay, today we are going to be dissecting the concept of linear programming. So, like I told you when we started optimal product mix, I mentioned that linear programming and optimal product mix are similar because the two of them, they involved the allocation of limited scarce resources. All right. So we just finished optimal product mix and we are moving to linear programming. And so I'll be very happy if we can complete this topic today. If not, wherever we stopped, then we'll continue next time. Okay, what do you mean by linear programming? You can say that linear programming involved the allocation of limited scarce resources among competing product lines in a judicious and efficient manner in order to achieve the organization's single economic objective. Okay, that is linear programming. When if you notice, that definition is almost the same thing. In fact, it's the same thing as the definition I gave to you under the optimal product mix. All right. However, the linear programming model is used to determine optimum production plan where there are multiple constraints, all right? When there are more factors of production that are limited in supply, then that is when you use linear programming for the purpose of determining optimal production plan. So that is linear programming. You recall that we said optimal product mix is used when there is only one constraint, but linear programming is used when there are multiple constraints. When there are more than one constraint, that is when you use linear programming for allocation. All right. However, when a company wants to produce raw material kilogram, labor hours, and matching hour may be needed for the purpose of manufacturing the company's final products in order to take advantage of market condition. But these factors of production are usually not sufficient in order to maximize contribution towards profit. Therefore, the limited scarce resources will need to be allocated among the competing product line in such a way that will enable the company to maximize contribution or minimize loss. To minimize cost. Okay, so this is linear programming. When you talk about limited scarce resources or factor of production, what we simply means is raw material kilogram, labor hours, or matching time. All right. So it is possible that material kilogram and labor hour may not be sufficient. Labor hours, matching time may not be adequate for the company to be able to take advantage of market condition. So when this happens, the little that the company has will need to be allocated that will enable the company to maximize contribution towards profit. Now, when it comes to linear programming, for linear programming model to be able to work effectively, there are some assumptions that must be considered. Let's talk about the underlying assumptions of linear programming. There are about five basic. There are more than five, but specifically, I have about five basic assumptions underlying linear programming. The first one is single economic objective. Single economic objective. This assumption states that there must be only one objective to be achieved. That is either to maximize contribution or to minimize cost. but not the two at the same time. All right. So for the objective for linear programming model to be able to work effectively, there must be only one objective, that is to maximize contribution or to minimize cost. Of course, you know that in practice, company can decide to achieve several objectives. So depending on the resources available, all right. So a company that is trying to maximize profit may also want to minimize cost. The company may want to satisfy customer demand. The company may want to enhance, excuse me, the company may want to enhance the customer's experience, customer satisfaction. All right. So there are several objectives that a company may want to achieve at the same time in practice. But as far as this model is concerned, we're saying that there must be only one objective to be achieved. The second one is linearity. Linearity simply means that the relationship between the objective function and other factors of production must be expressed in linear fashion. All right. So when you talk about linearity, let's say, for example, a company has 3 kilograms. A company has 3 kilograms of material A, sorry, of product A. All right. Then this is for material, for example. Let me close it. Let me shift it a little bit. Let's say, for example, a company has two products, A and then B. So this company has material. This company has 2 kilograms of material A, 3 kilograms of material B. All right. So let's say the total material available in this organization is 50 kilograms. That's total. So what we are saying here is that when you talk about linearity, all right, so we said that the relationship between the objective function and other factors of production must be expressed in linear fashion. So if I want to express this information, this material given to us, if I want to express it in linear fashion, I will just say 2A plus 3B less than equal to 500 kilogram. This is what we mean by linearity. All right. That's what we mean by linearity. Okay. Then the third assumption is certainty. This implies that certainty implies that the factor of production requires to manufacture the company's final products must be known in advance and with certainty. I repeat, certainty assumptions implies that the factor of production required for the manufacturing of the company's final products must be known in advance and with certainty. When a company wants to produce, you need to estimate how many kilograms of materials you are going to need, the number of labor hours that will be required, and then also the number of machine time that the company will use for the purpose of production. It's not that when you get to production setting or the production process, you now discover that you now say that, okay, I'm going to need this or I'm going to need that. All the resources that you are going to need for the purpose of production, you have to know them in advance and also with certainty. The fourth assumption is divisibility. All right, divisibility, which states that fractional output can be produced and that it is not compulsory that you have to produce the entire output. For sorry, I'm still battling with, for those of you that attended FM, I'm still battling with malaria since last week, Friday. Please bear with me. All right. So when you talk about divisibility, what we are saying is that fractional output can be produced. Let's say, for example, a company can produce one third of a particular product. The company can produce 99.1 units of a particular product. So a company can produce 70 units. So fractional output can be undertaken. All right. A company can produce fractional parts of the product. So it's not compulsory that it has to be 100%. So this is what we mean by divisibility. All right. Divisibility. And the last one is non-negativity constraint. Non-negativity constraint, which states that negative output is not permitted. All right. Negative output of a particular product is not permitted, and that the minimum that can be produced is zero. All right. The minimum a company can produce is zero. And you know that once a company produces zero, that means there's no production. All right. But you cannot have negative output. All right. So these are the five underlying assumptions of linear programming. I said the first one is single economic objective. Number two is linearity. Number three, certainty. Number four, divisibility. Then number five, non-negativity constraint. All right. So these are highly examinable. You have to know them. All right. You can't be talking about linear programming without you understanding the basic underlying assumptions. So you have to know them. All right. Now, what are the uses of linear programming? What are the uses of linear programming? You can call it uses, significance, or importance of linear programming. What do you use linear programming for? What are the areas of application of linear programming? All right. So you can just go through all of them. Of course, the first one is inventory management. You can apply linear programming in inventory management. You know, the primary objective of inventory management is to minimize the overall inventory cost. So you can use linear programming for the purpose of achieving that. You can also use linear programming for production management. All right. You can use linear programming for personnel management. Okay. You can use linear programming for financial management, particularly where there is no sufficient financial resources. So the limited scarce financial resources will need to be allocated, will need to be rationed. I'm very sure Mr. Ashwaji would have taught you capital rationing. All right. So you use linear programming to achieve that. All right. So these are some of the uses of linear programming. Like I mentioned, they're also very examinable. Please ensure you read them through. Ensure you read them through. You can read it and then summarize it. Then, before we talk about the um, formulation of linear programming, I won't take it that. I don't want to follow that route. I want to show you step by step. Let me see. What more do I need to tell you on this? Now, examiner can ask you, let me even see. Examiner can ask you limitation of linear programming. All right. So you have to know them. You have to know limitation of linear programming. Ensure you understand it. But let's talk about methods of determining optimal production plan. Basically, there are two methods of determining optimal production plan. Let me stop sharing this and move to the working notes. Yeah, basically, there are two methods of determining optimal production plan. One is graphical method, and then two, the simplex method. All right. So the graphical method is used for determining optimal production plan where there are only two variables, where there are only two variables. However, where there are multiple variables, when you have more than two variables, then simplex method is used for determining optimal production plan. Consistent with your syllabus, you only have the graphical method. Sorry, you only have the Yes, graphical method, and that's what we are going to concentrate our energy on. All right. So how do you determine optimal production mix? How do you determine optimal production mix or optimal production plan using graphical method? All right. So let me give it to you. Steps involved in determining optimal production plan using graphical method. To do this, there are about 7 steps you are going to carry out. When we determine optimal production plan using key limiting factor, I gave you about 7 procedures. Also, under the linear programming, there are 7 different procedures you are expected to carry out anytime you want to determine optimal production plan using linear programming. The first step, the first step is to define the variables. All right, define the variables. In most cases, the products that will be given to you in the question will be written in words, not in letter. Because when you want to construct your graph, you are going to use a letter, all right? But oftentimes, examiner will give to you the product in words. You can be given, examiner can tell you that product, product Zinco, all right? Product alpha, product beta. All right. So you are given such things, you need to convert it to a letter. Excuse me, you need to convert it to a letter. And that is what I mean by define the variables. All right. Let's say, for example, if you are given a product as Zinco, you are given another product as Mainco. So when you are drawing or you are constructing your graph, you can be using Zinco, Minco. So in this case, to define your variable, you can then say let Zinco equal to Z. For example, if you like, you can say let Zinco equal to A or X, whatever you use is what the examiner will mark for you. You can also say let Minco equal to M. So going forward, it is Z and then M that you are going to be using. So this is what I mean by define the variables. Then step two says formulate the linear programming model. LP. Formulate the linear programming model. To do this, there are 3 steps you are going to carry out. Anytime you want to formulate linear programming model, there are 3 steps. Step 1 is to state the objective function. Okay? State the objective function. To do this, you will go to the question, go and identify the objective that the company wants to achieve. Remember what I told you in the introduction. The objective, there is only, in order to achieve, there is only single economic objective that the company wants to achieve. It is either the company wants to maximize contribution or minimize cost. So you go to the question and identify the objective that the company wants to achieve. If in the question you can see contribution or profit, it means that the company wants to maximize contribution. If in the question you can see selling price, you can also see variable cost. you can see anything that will enable you to calculate contribution. It means that the company still wants to maximize contribution or profit. However, if in the question you don't have anything that relates to contribution, you cannot see profit, all what you can see in the question are purely cost, then it means that the objective that the company wants to achieve is to minimize cost. Okay, so I repeat, if in a question you can see selling price or variable, you can see selling price and variable cost, or you can see anything like that has to do with contribution or profit, then it means that the company wants to maximize contribution. But if in the question you can't see anything, sorry about that. If in a question you can't see anything that relates to those things that I mentioned, you can only see cost all throughout. A to Z of the question is all about cost. Then it means that the company wants to minimize cost. Certainly, it will be there in the question. You'll be able to see it clearly. All right. So how do you then state your objective function? So let's say the company wants to maximize contribution. So I would then come here, maximization of contribution. In this case, I have to go examiner. In most cases, examiner will not give you the contribution per unit. So you have to go to the question and determine your contribution. Contribution is selling price minus variable cost per unit or fixed cost plus profit per unit. So that will give you contribution per unit. Once you have your contribution, then you come and post. Let's say, let's be consistent with our the variables material, zinco and minco. So Z and M. So in this case, I would just say I would take the contribution of zinco. So let's say contribution of zinco is 100 naira, sorry, is 15 naira. So I would say 15Z plus the contribution of minco. Let's say contribution of minco is 12M. All right. So with this, I have stated the objective function. This is how to state the objective function. If it is minimization of cost, I will say minimization of cost. Whatever I have as the cost for each product, I will also put it there. The same way I've put the contribution. Then step 2, under the formulation, is to state all relevant constraints. State all relevant constraints. All right. So in the question, examiner will surely give you, the examiner will give you the production capacity. All right. Whether the material kilogram, the total material kilogram available, the total labor hours available, or the total machine hour, given all of them will be given to you in the question. You are going to see it clearly. So whatever it is, you just have to state your relevant constraints. Let's say, for example, material kilogram is not sufficient. So I can then come here, subject to, let's say we have material kilogram for product zinco is 3. What did I give the other time? Okay, not here. Okay, so let's say product zinco is 2 kilogram. So that will be 2, let me use another word. Let's say 3, because 2 and Z look alike. So let's say you have 3 kilogram of product zinco. So that would be 3Z plus, then you are given 5 kilogram of minco. So that will be 5M. So since we are maximizing contribution, it will be less than equal to, let's say the total capacity we have is 50 kilogram. So the maximum available material kilogram is limited to 50 kg. Therefore, with this, you can see that I've expressed relationship between the two products in linear fashion. This is what we mean by linearity. All right. That's what we mean by linearity. The same thing with the objective function. Okay. Then also, let's say we also have, remember, it's not when you're talking about linear programming, there must be more than one factor of production that is limited in supply. Let's say we also have labor hour. Let's say labor hour is also a constraint. So let's say, for example, you have 4Z, 4 hours of product Z. Then you are given 2 hours of product Minko, less than equal to, let's say the maximum labor hours available is 150 or 100. So 100 hours. So with this, we have stated the constraint. We have stated the labor constraint. All right. So let's say we only have only two. All right. Material and labor. So this is how to state all relevant constraints. If you have more than one, let's say you have machine time, you do the same thing. All right. But in most cases, this material kilogram, all right, or labor hour will not be given to you in the question. You are the one that will determine it. The same way we determine material kilogram under limiting factor, the same way we calculated labor hour is what we are going to do here as well. Then finally, step 3 for formulation of linear programming, you have to state the non-negativity constraints. State the non-negativity constraints. Remember, the non-negativity constraints says that negative output is not permitted and that the minimum that can be produced is 0. So in this case, I would then say non-negativity, non-negativity, which is equal to, I would then go to the question. What we are saying is that in this case, we have product Z and M, product Zinco and Minco. So you can then say Z and M must be greater than or equal to 0. So whatever we are going to produce for product Zinco and Minco must be greater than or equal to 0. All right, it cannot be less than 0. If it is less than 0, that means you are producing negative output, which is not appropriate. So this is how to formulate a linear programming model. So you can put it in a table. So I can just come here, I will say objective function. On the day of your exam, no need to put it in a table. It's a waste of time. So objective function, all right. So maximization, here is maximization of contribution, which is equal to, we said 15Z, 15 naira of product Z plus 10 naira, 12 naira of product Minco. All right. Then you also state the non-relevant all relevant constraint, which is subject to, we said we have 3Z plus 5M less than equal to 500 kilogram. Then we also have, this is for material. Then we also have labor. Labor is 4Z plus 2 Minco less than equal to 100 hours. All right. Then the last one is non-negativity constraint. We said Z and M must be greater than or equal to 0. All right, so if you want to put it in a table, this is what you are going to put it in your table. Okay, so like I said, on the day of your exam, no need to be putting it in a table. But if you put it in a table, it will just make your work look better. All right, no, it's not compulsory. So this is anytime you are asked to formulate linear programming model, this is what you are supposed to do. All what I have here, all what I have here is what I've put in the table. Okay. Then step 3 for determining optimal production plan. Step 3. Step 3 is to bring out the equation in step 2. Bring out all the equations in step 2 and solve using elimination method. So whatever you have put here, whatever you have put here in your step 2 in your formulation, all the equations that you have there. Let's say, for example, now this is one equation here. This is equation 1. This is equation 2. You bring them out. You then solve using the elimination method. Step 4. Step 4 says you should construct a pivot table. All right, construct a pivot table using the results of step 3. Whatever the result that you have here is what you are going to put in your pivot table. Then step 5, you construct a graph. Okay, construct or draw a graph. And indicate a feasible region. All right. Then step 6, you construct solution table. Construct the solution table. This is where you are going to make the final decision. Then step 7, you determine optimal production plan. If you want to make it step 8, then step 8, you can then say determine the profits. Oftentimes, examiner can ask you to determine the profit derivable for your allocation. So these are technically 8 procedures that are supposed to carry out anytime you want to determine optimal production plan. All right. So this is on one side. Now, after you have determined the optimal production plan, examiner may want you to determine shadow price. So what do you understand by shadow price? What are the methods of determining shadow price? Let's talk about them before we begin to solve questions. All right, let's talk about shadow price. So what do you mean by shadow price? Shadow price represents, let me just put it down. This represents the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. So that is shadow price. It represents it represents the amounts. It represents the amounts a company will pay for additional units for additional units of scarce resources. Okay. So it should be noted that it should be noted that only resources at the optimal activity level, only resources at the optimal activity level that is at the point where decision is made we have a shadow price. We can call it shadow price or dual price. Now, what are the methods of determining shadow price? So what are the methods of determining shadow price? Basically, there are two methods of calculating shadow price. Of estimating shadow price, including one, dual method. Then two, increase the number of constraints by 1. So these are the two methods of calculating shadow price. It should be noted that any of the two methods above will produce the same amount of shadow price. So it's the same result you are going to have. Whether you use dual method or you use increase the number of constraints by 1, whichever one you use, you are going to get the same answer. All right. So what are you supposed to do if you want to use the dual method? If you are using dual method, you are going to carry out about 3 steps, 3 or 4 steps. Step 1, identify the equations that intercept, or identify the equations at the optimal identify the equations at the optimal activity level. So the two equations that intercept at the point where the final decision is made, that is the optimal activity level. Whatever the equations that you have there, you picked it. Then step 2, you find the dual. Find the dual of the original equation. That is, find the transpose. That is the transpose of the original matrix. That's step 2. Then step 3, solve the dual problem using simultaneous equation. The resultant figure, whatever you have in step 3, will represent your shadow price. So these are the 3 procedures you are going to carry out anytime you want to determine shadow price using the dual method. Then, using the increase the number of constraints by 1. If you want to use the increase the number of constraints by 1, there are about 5 or 6 procedures. I can shorten it to 4. All right? Increase the number of constraints by 1. If you want to increase the number of constraints by 1, so there are about, like I said, there are 6 steps, but I will reduce it to 4. The first step is to identify the equations that intercepts at the optimal activity level. Then step 2, you increase the number of constraints, increase the constraints by 1. Increase the constraints of the first equation by 1 and solve simultaneously. Both the two methods make use of a simultaneous equation. Then step 3, you determine or calculate when I write it. Calculate a new contribution margin. Calculate a new contribution margin using the result of step 2. Using the results of step 2. To multiply the contribution. Then step 4. So whatever you have in step 3, we give you the shadow price. Okay, let me complete that. Calculate the new contribution using the result of step 2 to multiply the contribution and deduct the new contribution from the old contribution margin. The difference is the shadow price you are looking for. Then step 4. Like I said, there are about 6 steps, but I will crash it to 4. So step 4, repeat step 2 and 3 above for the second constraint. All right. So, so these are the procedures that you are going to carry out to determine the shadow price. So like I mentioned, whichever method that you use, you are going to get the same answer. The dual method is faster and straightforward, unlike the increase the number of constraints by 1. That one is more cumbersome. So always use the dual method and move on. All right. So that's that. At this point, we can then have illustration. Let's have illustration. Okay. Let me go back to your material and see if I have other thing that I need to mention that I've not mentioned. Okay. I've talked about the uses. I also advise that you should form a note on the limitation of linear programming. So we have talked about concept of shadow price. So at this point, we can have illustration. Let me check the golden book. Let me see if there's additional information there I need to push out. Um, Let me quickly open it. Okay. All right. Let's talk about the optimal mix. Linear programming. Okay. I just want to check if there are other things I need to mention. So like I said, ensure you have you copied, you form a note on the limitation of linear programming. All right. I think that's it. That's it. It's not more than that. It's not more than that. Um, yeah, that's it. Okay. So let's have illustration. So let me share. So we can't solve more than two illustrations. Usually it takes time. All right, so I will advise you on the day of your exam. If you are given a question on linear programming, please don't make it your first attempt. All right, don't make it your first attempt because it takes time, particularly if you have a question that involves shadow price. All right, you can still be spending like 45 minutes. You are still on it. You won't know that time is good. You'll be enjoying it, even though it is very straightforward and easy to understand. But because it takes time. But if the question is, if it's a compulsory question, of course you have no choice, but don't make it your first attempt. Go and look for easier questions. The question you can solve within 15, 20 minutes. So you can pocket like 3 or 4 of them. Then you can come and balance on the compulsory. That's what you should do. So we are going to solve this one. Illustration 2. Then the last question tested. This is illustration. Yes, we're also going to solve this. Illustration number 6 on that's the last question tested on linear programming. All right, so let's start with the first one. Let's start with the first one, Akanchawa Limited. Let me read for you. Akanchawa Limited has the following data relating to its product, Toro and Kobo. You are given information about selling price and variable costs. Assume all the information there are correct. Fixed overhead is budgeted as 275,000 naira per annum. Relevant data for each department are, so we have information about employee in each department, the number per week, and then the number of employee per week, hours per employee, then wages rates. In the present environment, it is not possible to engage any more employees. So examiner has told us that in the present environment, it is not possible to engage any more employees, which means that labor hour is the limiting factor. Labor hour is the constraint in this question. because you are told that it's not possible to employ any more employees or to engage any more employees. So you are required to, one, formulate the linear programming equation and show on a graph the mix of products which will maximize the contribution of the company. So the objective function for Akanchawa is to maximize contribution. What is the resulting profit? That is the second thing you are going to do in number one requirement. Then two, determine the shadow price. So this is the question. In the number one requirements, first thing first, you formulate the linear programming model. Then you determine the mix of products that will maximize contribution. That's two. Then three, you determine the resulting profits. So 3 in 1. All right, 3 in 1. That's for requirements number one. Then number two, you have to determine shadow price. So let me stop sharing this. Open to the material at your end so that we can follow through together. Let me move to the working notes quickly. Okay. Solution. So illustration 2. Okay. Page 46. The name of the company is Akanchawa Limited. Now, like I told you, anytime you want to determine optimal production plan, there are 7 key steps that you are supposed to carry out. The first step is to define the variables. All right. In this case, if you say define variable, don't need for you to say define the variables. Just come here, or you can just put it there. Variables. Just put variables. Under the variables, you can say you can see that we have 2 products, product Toro and then Kobo. When you are constructing your graph, you can't be using Toro and Kobo. Therefore, you have to represent them with a letter. So in this case, you can say let Toro equal to, if you like, you can say A. If you like, you can say M. Or if you like, you can use the first letter of the product. Let's use the first letter. Let Toro equal to T, then Kobo equal to K. So with this, we have defined the variables. We then move to step 2. Step 2 says formulate the linear programming model. So you can say formulation of linear programming model. So like I told you, to formulate linear programming model, there are 3 steps. Step 1 is to state the objective function. Under the objective function, I will then go to the question. What objective does this company want to achieve? According to the question, we are told to formulate the linear programming model equation and shown on a graph the mix of products which will maximize contribution of the company. So the objective is to maximize contribution. So I can then say maximization of contribution. So I will go back to the question and identify contribution given to me. In the question, we are not given contribution margin, so we need to compute it by ourselves. Therefore, without going too far, let's use the second page for our contribution. So calculating contribution per unit. So we have T and K. For T and K, total and cover. I will go back to the question to identify how I'm going to calculate my contribution margin. So in the question, I'm given selling price. I'm also given variable cost. Then in that case, selling price minus variable cost per unit will give me contribution per unit. So I will then say selling price for T is 200, for K is 240. I will then less variable cost. How do I calculate my variable cost? I will go back to the question. You are given direct material cost, 45 and 15 naira. Direct material, 45 and 50. I'm also given direct wages. Direct wages is the same thing as direct labor. We have three different departments. So for department number 1, direct wages is 16 and 20. Minus 16 minus 20. We have department number 2, which is 22.5, 13.5. 13.5. We also have department number 3. And then direct wages of department number 3 is 10.30. 10.30. Then we have variable overhead. All right. And according to the question from the table, variable overhead is 6.5 and then 11.5. So at this point, I will then find the difference. The difference will give us contribution per unit. So what do you have as the difference? Are we together? Okay. Let me use my calculator. 16.5 plus
For product C is 100.
T is 100, okay. 50, 70, 100, that's 250. No, 50, 70, 100, plus 100 plus 25. That's 125.
For K is 15.
That's 115. Okay. All right. So contribution per unit for T is 100 naira. For K is 115 naira. Now that we have the contribution per unit, I can then go back to my calculation. I will then say 100 naira of T plus 115 naira of K. So with this, I've stated the objective function. Step 2 of this is to State all relevant constraints. When you are doing your main calculation, no need to say states relevant constraint, states objective function, states non-negative. You don't need all of that. Just go straight to the point. So here I would then say subject to. That is, for the company to be able to achieve the objective, it is subject to the following constraints. So I will then go to the question, what are the constraints given to me? Examiner has told us in the question that it is not possible to engage. It is not possible to engage any more employees. So that means labor hour is the labor hour is the constraint in the question. However, we have department one, we have employees in department one, two, and three. Therefore, so I can then come here subject to the first one is department one. Department two, department three. So let's go and calculate labor hour per unit. All right, labor hour per unit for each of the departments. So I will then come here also labor hours per unit. How do I calculate my labor hour? Please, I beg of you, on the day of your exam, don't make your working in between your solution. Your working should be the last thing. But because I don't want to be switching pages, that's why I have to do it in my second page. I have to do working in my second page. Ordinarily, working should be the last thing. It should be on your last page. So watch out. Okay then. Now, how do I calculate my labor hour per unit? I will go back to the question. The information will always be there for you in the question. Okay? So how do I get my labor hour? Remember, labor hour represents labor cost divided by labor rates. So labor hour per unit is equal to labor cost divided by labor rates. This is the same formula I gave to you when we had optimal mix. So for department one, let me use a table. So for thorough and then cover. So department one, under department one, direct labor cost for department one is 16 naira, 20 naira for cover. So wage rates for department one is 2 naira. Therefore, 16 naira divided by 2 naira. There will be 16 divided by 2. That's 8 hours. Then department one for K. This is 20 naira, then divided by 2 naira. 20 divided by 2. This will give us 10 hours. Then for department 2, do the same thing. For department 2, 22.5. Wage rate for department 2 is 2.25. 22.5 divided by 2.25. What do we have here? That should be like 10. That should be 10 hours. Let me shift a little bit to the left. 22.5 divided by 2.25. So this should be 10 hours. Then the other side, for K, 13.5 divided by 2.25. So this should be 13.5 divided by 2.25. What did I do? 13.5.
6 hours.
What did you say it is?
6 hours. 6 hours.
6 hours. Okay. Here is 6 hours. Then for department 3, labor cost for T in department 3 is 10, then 30 for K. Wage rate is 2.5. So 10 naira divided by 2.5. So that will give us 4
4 hours.
hours. Then 30 naira divided by 2 naira 50 kobo. That should be 12 hours, I think. Let me confirm. So with this, we have determined labor hour per unit for each department. So like I told you, you must know what you are doing. All right, so this is what we are going to use to state our constraints. Now, you also need to determine the maximum production capacity. What is the total available labor hours? Working number 3. Total available. Examiner did not give us total available labor hours. Therefore, you are the one that will determine it yourself for each department. This is working number 2. This is working number 1. Okay. How do you determine your total production capacity? So for department 1, examiner has told us in the question that it is not possible to engage any more employees. So if that is the case, you are given relevant data for each department. For department 1, there are 20 employees in department 1. Sorry, the number of employees in department 1 is 20. Hours per unit, each of them will spend is 40 hours. Therefore, 20 multiplied by 40, we are going to need 800 hours. 20 employees multiplied by 40 hours per employee. This will give us 800 hours. For department 2, how many employees? We have 15 employees multiplied by 40. 15 multiplied by 40 should give us 600 hours. Then for department 3, we have 18 employees multiplied by 40 hours per employee. This should be 720 hours. So the total available labor hours for Department 1 is 800, Department 2, 600, Department 3, 720. So these are the information that you need for you to be able to continue. Therefore, let's go and put it down. Now, hour per unit for Department 1. For K, 8, then 10. So I will then come back here. 80 plus 10K. Because we are maximizing contribution, it will be less than equal to, if you are minimizing cost, it will be greater than equal to. So I repeat, if you are maximizing contribution, your sign should be less than equal to, but if you are minimizing cost, it should be greater than equal to. So watch out. So the maximum labor hours available for Department 1 is 800. Then for Department 2, labor hour per unit is 10 and then 6. 10 and 6. 10 hours of product T plus 6 hours of product K less than equal to 600 hours. Then for Department 3, 4 hours of T plus 12 hours of K less than equal to 720 hours. So with this, we have stated the relevant constraints. We then move to step 3 of the formulation of linear programming model, which is to state the non-negativity constraint. The non-negativity constraint states that negative output is not permitted. So we have two variables, T and K. Therefore, you can then say T and K must be greater than or equal to 0. So with this, we have formulated the linear programming model. So we then move to step 3. Step 3 of determining optimal production plan. Step 3 says you should bring out all the equations. No need for you to say bring out the equation and solve using elimination method. You can just say elimination, or you can just say equation. We have 3 equations. Equation 1, equation 2, equation 3. So bring them out and solve using elimination method. So 80 plus 10K equal to 800. That's equation 1. Then 10T plus 6K equal to 600. Equation 2. 40 plus 12K equal to 720. Equation number 3. We then solve the equation using the elimination method. All right, so bring out the first equation. Let's continue from here. So the first equation is 80 plus 10K equal to 800. All right, equal to 800. You then say, because we are using elimination method for the purpose of this class, let me just put it there. Using elimination On the day of your exam, you don't need it. Just carry on with your calculation. All right, using the elimination method. So you first of all bring out the equation. You then say we are going to eliminate one variable, and then you solve for the other variable. Once you have solved for the other variable, then you eliminate the first variable. Sorry, you use the first you determine value for the first variable, then you eliminate the other variable. So you can say let t equal to 0. If t is equal to 0, then you multiply 8 multiplied by 0. That will be equal to 0. So just say let t equal to 0. So if t is equal to 0, then 10k will be equal to 800. Therefore, k will be equal to 800 divided by 10. So k is equal to 80. Again, you can say let k equal to 0. If k is equal to 0, then 80 will be equal to 800. Therefore, t will be equal to 800 divided by, let me use division sign. So 800 divided by 8, that should be 100. All right, so I'm done with the first equation. I will then move to the second equation, which is 6t. Is it 60? Yeah. Second equation is, sorry, 10t plus 6k. 10t plus 6k equal to 600. This is equation 2. All right. So then say let t equal to 0. If t is equal to 0, then 6k will be equal to 600. Therefore, k will be equal to 600 divided by 6. That's 100. What's wrong with you? Don't waste my time now. My phone is not connecting. What's wrong with you? Okay. Uh, I don't know why. Ah, are you angry? Please don't be angry. Don't be angry. Let me do my workers. It's back. So here is 100. Again, you can say the first one we eliminated the t. Let's eliminate k now. So let's say let k equal to 0. If k is equal to 0, then 10t will be equal to 600. Therefore, t equal to 600 divided by 10, which is equal to 60. Then the third equation is 4t plus 12k equal to 720. This is equation number 3. You then say let t equal to 0. If t is equal to 0, then 12k will be equal to 720. Therefore, K will be equal to 720 divided by 12. Okay, so what do you have? 720 divided by 12. 720 divided by 12. That's 60. Then again, you say let's K equal to 0. If K is equal to 0, then 40 equal to 720. Therefore, T equal to 720 divided by 4. This should be 180. Let me confirm. I think that's correct. 720 divided by 4. Yeah, that's it. So that's all you need to do. Now that we have converted each of them, the next thing we are going to do, step number 4. Step number 4 is to then construct a pivot table using the result of step 3. Pivot table for Toro and Kobo. So the first equation is 80 plus 10K. 80 plus 10K equal to 800. The second equation is 10T plus 6K equal to 600. And the third equation is 40 plus 12K equal to 720. All right. Okay. For the first equation, when T is equal to 0, here is the first equation. When T is equal to 0, K is equal to 80. And when K is equal to 0, T is equal to 100. So this guy was 0, 80, then 0, 100. All right. Next one. When T is 0, K is 100. And when K is 0, T is 60. 100, 60, 100. When T is 0, here is 100. When this is 0, this is 60. Let me confirm. So that I don't give one belongs to Peter to Paul. K is 100, then T is 60. Yeah. The next one. Equation number 3. When T is 0, K is 60, and then when K is 0, T is 180. So 180, 60. 180, then 60. So this is your pivot table. Step number 5 says we should construct a graph. Step 5, graph. Now, when you are constructing your graph, you have to make it very bold. All right? Don't make your graph too small, all right? So make it very big. So to do this, remember, one of the underlying assumptions of linear programming is that negative uh, output is not permitted, that is non-negativity constraint. So you can, when you are constructing your graph, unlike other mathematics or statistics, whereby when you are constructing a graph, you can have negative axis and you can also have positive axis. So that does not apply under linear programming. All right, because negative output is not permitted. So to construct your graph, like I said, you have to make it very bold. So I can do like this. Okay. I can also go to the other side. So the starting point is 0 because the minimum that can be produced is 0. All right. So we then plot Toro against Cobalt, T against K. We go back to our pivot table because you are going to use your pivot table to construct your graph. From the pivot table, the highest figure for T is 180. The lowest figure for T is 60. Again, for K, highest figure is 100, lowest figure is 60. So the essence of doing this is the reason why you want to check the highest and the lowest for each of the variable is for you to know how to scale your graph. All right. So we can use 50 for both of them. We can use 50, or we can use for K. We can use 50. Then for T we can use 50. For K we can use 20. All right. So let's say this is K axis, then this is T axis. All right. So you are plotting T against K. So for the first equation, let me first of all scale it. All right. So you can say, let's make this one to be 50. Let me rewrite the axis. Let's make this one to be 100. This is 150. Then this is 200. Okay. Let me extend. All right. So this is T. And this is X. This is 20. 40. 60. 80. And then 100. Okay. So you then plot T against K. For the first equation, when T is equal to 0, K equal to 80, and when K is equal to 0, T equal to 100. You don't need to waste time to be doing that. Just go to where you have T for the first equation. Go and asterisk 100. Here is T. So you asterisk 100 here. Let me see. Let me change the color of my, let me change it to red. So here is 100. You asterisk it. Then this other guy for K, sorry, for K is 80. So 80 will be here. Then you join the two together. Let me return it to my normal blue. This is K. So you then join the two. All right. So you can write out the equation. The first equation is 80 plus 10K. This is equation 80 plus 10K equal to 800. You then do the second one. The second equation is T is 60, K is 100. T 60, K 100. So go to where you have T. Go on asterisk 60. Let's say 60 is somewhere here. Now, on the day of your exam, you may not be given graph sheets. If you are not given graph sheets, the same way I'm doing it is the same way you are going to do it. All right. But if you are given a graph sheet, that will be very easy. All right. So this is 60. Let me write that. Then K is 100. Here is 100. Again, you join the two of them together. You join 60 and 100 together. So you write out your equation. This is equation 10T plus plus 6K equal to 600. Then the third one, the third equation is T is 180, K is 60. So you are going to plus 180 versus 60. 180 should be somewhere here. Let's say 180 is somewhere here. All right. Then for K is 60. Here is 60. So we then marry the two of them together. Okay. 180, then 60. Wow. This is difficult for me. Oh. Let me manage. Okay. So you write out the equation as well. This is equation 40 plus 12K equal to 720. So at this point, the next thing we need to do is to then determine the point of intersection. We need to determine the point of intersection between T and K. All right. So to get the point of intersection, T and K, remember, because we are maximizing contribution, your point of intersection will be internal towards 0. If you are minimizing costs, your point of intersection will be external outward 0. All right. So T and K intercepted at 60, at this point where you have 60. Let's say that is point A. They also intercepted at this point here. Let's say that's point B. They intercepted at point 60. Let's say this is point C. So these are the 3 points of intersection between between products A and K. All right. So here we represent your feasible region. All these points, the point of intersection towards 0 are your feasible region. All these areas that are put dotted lines, they are the feasible region. All right. But if you are minimizing costs, your feasible region will be external. In this case, it will be somewhere here. It will be all these places out towards 0 to then determine your point of intersection. In this case, here will be the first point. Here will be another point of intersection, another point of intersection, another point of intersection. But because we are maximizing contribution, so no need to do that. Okay, then. Next, we need to determine value. We need to determine value for points A, B, C. We need to determine value for K and T at point A, B, C. So I can then say at points A, B, and C, we want to determine value for T and then K. If you like, you can put it in a table. Okay. Now, we need to determine value for T and K at point A, B, and C. Here is point A, where you have 60. That's point A. At that point A, what is the value of T? Value of T is 60. So here will be 60. At point A, where you have this red dotted line, that's point A. What is value of K at that point A? When you trace it down, value of A is equal to 0. Value of K is equal to 0. So I'm done with that. Next one. At point B. Point B is here. This is point B here. All right. At that point B, what is the value of T? What is the value of K? So we cannot get, because we are not using graph sheets, there is no way we are going to get the value of K and T accurately at point B. Therefore, we skip it. We'll come back to that one later on. But if you are given a graph sheet, then you can just trace to the left, then you trace downward. Whatever you have thereafter will be the value of T and K. Then at point C, here is point C, where you have 60. Here is point C. All right. So at that point C, value of T, you trace it to the left. Value of C is 0 because on a straight line. Here is 0. Then value of K is 60. So that's that. So before we proceed, we need to get the value of T and K at point B. So I can then say to determine, to get the values of T and K at point B. Step 1. Step 1. Identify the equation. Identify the equations that intercept at point B. Then step 2. Solve the equation simultaneously. So that's what you need to do to get the value of T and K at point B. So at this point, I will then go back to my diagram, to my graph. From my graph, here is point B. At this point B, this equation of 60 to 100 intercepts. That is this. This is this equation here. Also, at point B, this equation that went up like this, 180 to 60, that's equation 3. They also intercept at that point B. So those are the two equations that intercepted at point B. So I will then bring them out. So from the graph above, at point B, the equations at point B. So we have equation 10t plus 6k. 10t plus 6k equal to 600. Then 4t plus 12k equal to 720. So these are the two equations that intercepted at point B. We then solve the two equations using simultaneous equation. So using simultaneous equation, you multiply the first equation, multiply the first equation by the first figure here. So here will be 4 multiplied by 10t plus 6k equal to 600. Then you multiply the second equation by the first figure in the first equation. So 10 multiplied by 40 plus 12k equal to 720. So 4 multiplied by 10 will give us 40t plus 4 multiplied by 6, 24k. 4 multiplied by 600, 2,400. 10 multiplied by 4, 40t. 10 multiplied by 12, that will give us 120k equal 10 multiplied by 720, that will be 7,200. Equation 1 will cancel the other one. 40 will cancel 40. Therefore, 120k minus 24 minus 24K equal to 7,200 minus 2,400. Here will be 96K equal to 4,800. Therefore, K will be equal to 4,800 divided by 96. So K equal to what? What do you say is the final answer?
50.
50. All right. So K is equal to 50. We then substitute for K in any of the equation. Let's use equation 1. Whichever one you use, you get the same answer. So here is equation 1, 10t. Anywhere you see K, you put 50. So 10t plus 6K, that is 6 multiplied by 50, equal to 600. 10t plus 300 equal to 600. 10t equal to 600 minus 300. Therefore, t equal to 300 divided by 10. So t I've started again. Don't waste my time. Why are you wasting my time now? My pen is not connecting. I will see. So, 300 divided by 10. So t equal to 30. T equal to 30, K equal to 50. All right. So I will then go and put it there. On the day of your exam, no need for you to come and be putting question mark. Just leave it blank. Go and do your working, then come and post. So we said T equal to 30, K 50. Here is 30, here is 50. So if you are using a graph sheet, at this point B, if you trace it to your left, you are going to have 30. At this point B, if you trace it down, you are going to have 50. That is if you are using a graph sheet. But if you are not given a graph sheet, the same way I'm doing it is the same way you are going to do your own. All right. I don't know if ICAN is still given the graph sheets in the exam hall. All right. Now that you have determined the value for each point of intersection for T and K, we can then proceed to construct a solution table. Step 6. Step 6, solution table. You can see what I was telling you the other time that usually takes time. We have not done the shadow price though. Solution table. So in the solution table, if you like, so you can state your objective function. You repeat your objective function. Of course, the contribution of T is 100. So here will be 100 100 naira of T plus 115 naira of K. Then you're going to have total. Okay? So at point A, point B, point C, all the figures that we have in step 5 is what we are going to use here. All right. Anywhere you see T, you put 60. Anywhere you see K, you put the value you have there in your graph. Okay? So, let me complete my table. All right. What's wrong with you? Ẹ má bínú. I don't know why the cough has refused to go for like a week now. Okay. Yes. Here will be 100 multiplied by, at point A, the value of T is 60. Value of K is 0. So 100 multiplied by 60 equal to 6,000. Then 115 multiplied by 0 equal to 0. Okay? Then 100 at point B, 100 multiplied by 30, K multiplied by 50, 100 multiplied by 30, that will give us 3,000. Then 115 multiplied by 50. What do we have there? 115 multiplied by 50. 5,750. 5,750. Then 100 multiplied by 0 will give us 0. 115 multiplied by 60. 115, 115 multiplied by 60. 6,900. 6,900. So you are going to add the total contribution of T and K at each point. So 6,000 plus 0 will give us 6,000. 3,000 plus 5,750 will give us 8,750. 0 plus 6,900 will be 6,900. Now, step 7 is to determine the optimal production plan. To do this, first thing first, you need to make a decision. The highest point, when you are maximizing contribution, you are going to select the highest total contribution. If you are minimizing costs, you will select the lowest total cost. So, because at point A, our total contribution is 6,000. At point B, total contribution is 8,750. And at point C, total contribution is 6,900. Therefore, this will be our optimal level of activity, 8,750. So our optimal level of activity is at point B. So I can then say production or optimal production plan. If you like, you can put it in a table. So products, units, for products T and K. For T, this is the optimal level of activity. It means that we are going to produce 30 units of product K, then 50 units of 30 units of T, 50 units of K. That's the optimal level of activity. These are the optimal production plan that will maximize contribution and profits. If you want to put it in words, you can then say that Akanchawa Limited should produce 30 units of toro and 50 units of cover to maximize total weekly contribution. Total weekly contribution of 8,750 naira. So that's that. That's not the end of the question. Examiner told you that you should formulate a linear programming equation. We've done that. Show on a graph the mix of product that will maximize contribution. We've done that. What is the resulting profit? The next we want to do is to determine the resulting profits. Weekly profits. So examiner told you to determine the resulting profits. So in this case, examiner was not specific. You are not told whether it should be annual profit or weekly profits. So I would advise you, if you are faced with this kind of a situation, I will advise you do the two. You do the weekly, you do the annual profit, because in a question, the information given to you are weekly. However, the fixed overhead given to you is annual. So if you want to use weekly, I will then come here to get profits. Remember, profit is contribution less fixed cost. Therefore, I will then come here, contribution. Weekly contribution is 8,750. Weekly fixed overhead will then be equal to the total overhead given to us in the question is 275,000 naira per annum. So we can convert that to weekly overhead. So I can then say 275,000 divided by 52 weeks divided by 52. So our assumption is that we have 52 weeks in a year. If you assume that there are 50 weeks in a year, then you divide it by 50. So 275,000 divided by 52. That's 5288. 5288. Then find the difference. All right, 8750.
3.62.
3462. All right. 3462. So you can then say the resulting profits, the resulting weekly profits is 3,462 naira. Notes. It is assumed that there are 52 weeks in a year. All right. So you have told the examiner that you assume 52 weeks for a year. If you assume 50, do the same thing. So alternatively, if you want to calculate per year, annual profits, because examiner did not tell us to calculate annual profit or weekly profit, so you are at a liberty. So if I want to calculate annual profits, then I will have to convert my weekly contribution to annual contribution. Annual contribution will then be equal to weekly contribution of 8,750 multiplied by 52 weeks. So what do you have? Yes? What do you say is the answer?
55,000.
I guess, I don't know what is my net. Did you say 455?
Yes, sir, 455,000.
I don't know what is my network. Okay. 455,000 minus 275,000. What's the difference?
180,000.
So 180,000 is the annual profit. So like I said, if you are faced with this kind of a question on the day of your exam where examiner is not specific, you can do the weekly and you do the annual. So examiner will pick anyone he or she wants. All right. So we just finished requirement number 1. So requirement number 2 says we should calculate shadow price. So quickly, let's do that. And that's where we are going to stop for today. Shadow price. Let me extend my table or my sheet. Okay. Shadow price. Number next. Calculating shadow price. We said that shadow price represents the extra contribution derivable from the additional units of limited scarce resources that have been fully utilized at the optimal level of activity. Only binding constraint will have a shadow price. Okay? So to determine shadow price, I told you we can either use dual method or increase the number of constraints by 1. Whichever method that you use, you are expected to get the same answer, except with a little rounding, if any. Therefore, let's use dual price. Okay, let's use dual method first. If we have time, we are going to demonstrate the two. dual method. So using the dual method, there are 3 steps you are going to carry out. Step 1, identify the equation that intercepts at the optimal level of activity. Pay attention to this. Our optimal level of activity is where we make the decision, and which is point B. Point B is where we made a decision that the company should produce 30 units of thorough and then 50 units of cobalt. That's the optimal level of activity. So step 1 is to identify the equation that intercepted at that optimal level of activity, which is point B. I will then go back to my graph. Where is point B? I think we have done it before. Yes, it's the same point B. These are the equation here. So this is the point B on our graph. This point here is the point B. That's the optimal level of activity, and we have identified the equations, which is originally equation number 2 and 3. Okay, so that's the first step. So I can say the equations that intercept, or let me put it this way. Point B in the graph above represents the optimal level of activity. Okay. Therefore, at point B, we have 10T plus 6K equal to 600. We also have 4T plus 12K equal to 720. All right. So these are the 2 equations that intercepted at that point B. Then step 2 says you should find the transpose of the original equation. This is the original equation. I can rewrite the original equation to say 10T plus 6K equal to 600. Then I have 4T plus 12K equal to 720. Then the contribution of T is 100 plus contribution of K 115. So this is the original problem. This original matrix or original problem. Then to find the dual problem, you are supposed to change, to find the dual, you are supposed to find the transpose of original matrix by changing column to row or row to column. All right. So this is the original matrix. So if I want to get the dual problem, I need to find the transpose by changing row to column. All right. So to do this, the first row, which is 10T plus 6K plus 6 equal to 600, I will change it to column. So in this case, here will be 10, 6, then 600. I've changed row to column. The second row is 4T plus 12K equal to 720. So here will be 4, 12, 720. The third row, where you have the contribution, Then here will be 100, then 115. Now, the issue is that when you are finding dual problem, all the information you have in the original matrix will change. That's why we are changing row to column or column to row. The letters that you have, in this case, we have letter T and K. The letters will also change to another letter. Everything you have in the original problem must change. In the original problem, we are maximizing contribution. As we are finding transpose, we are going to change to minimization of cost. Okay? Therefore, this is the dual problem. This is the dual. So in this case, we can use any letter. If I like, I can say this is 10A plus 4B equal to 100. The contribution has changed to constraint now. Then 6A plus 12B equal to 115. The constraint we have before has now turned to cost. Here will be 600 of A plus 720 of B. So that's it. We have found the dual problem. Step 1 says identify the equation that intercepts at optimal level of activity. That's what we have done. This is it here. Then step 2 says solve the problem. Find the dual of the original problem. That's what we have done. Then step 3 says solve the dual problem using simultaneous equation. So I would then say, let me make it clear to you. Okay, I think maybe when I'm solving the second illustration, but for now, let me just continue. We're almost, time is almost up. It's all right. So solve the dual problem using simultaneous equation. To do this, I would then say this is the dual problem now. The equation in the dual problem is 10A plus 4B equal to 100. Then 6A plus 12B equal to 115, equation 2. You then multiply the first equation by the first figure in the second equation. So 6 multiplied by 10A plus 4B equal to 100. You multiply the second equation with the first letter, with the first figure in the first equation, which is 10 multiplied by 6A plus 12B equal to 115. So 6 multiplied by 10 is 60A. 6 multiplied by 4, 24B. 6 multiplied by 100 is 600. 10 multiplied by 6, 60A. 10 multiplied by 12, 120B. 10 multiplied by 115, that's 1,150. 60 will cancel 60. So 120B minus 24B equal to 1,150 minus 600. So here will be 96B equal to 550. Therefore, B will be equal to 550 divided by 96. So B will be equal to what? 550 divided by 96.
5.73.
That's 5.7. 5 naira 70 kobo. This is the extra contribution. Then substitute for B in any of the equation. Let's use equation 1. Anywhere you see B, you put 5.7. So the first equation is 10A plus 4B. 10A plus 4 into 5.7 equal to 600. Is this 600? Okay, so 10A plus 4 multiplied by 5.7, that
22.8.
22.8 equal to 100. So 10A equal to 100 minus 22.8. Therefore, A would then be equal to 77.2. Yeah, 77.2 divided by 10. So A will be equal to 7.7. All right. A is equal to 7.7. So the constraint, the extra contribution will be derived from department 2 and 3. All right, because the two equations that are intercepted at this optimal at this point B, those two equations, they are for departments 2 and 3 in our graph. Yeah, this 10T plus 6K, then 4T plus 12K. This is department 2. This is department 3. All right. So we can only get extra contribution from department 2 and 3. So I can then come here to say shadow price. All right. In Naira, department 2, department 3. Here is 5.7, here is 7.7. So if you like, if you want to put it in words, you can say the extra contribution derivable. Remember, we said that shadow price represents the extra contribution derivable from the additional units of limited scarce resources that are be fully utilized at the optimal level of activity. So this is where we are going to call it a day. In our next class, by the grace of God, I'm going to solve the second illustration. I will demonstrate using both um, dual method as well as increase the number of constraints by 1. So anyone that is more convenient for you. But because time is already fast spent, so I can't do the second method. But in our next class, of course, that's the only solution we are going to have in our next class. Then we'll move to another topic. All right. Let me see. So let me know if you have any question for me so that we can close the class for today. Some of you have disappeared. No worries. Let me see. Those of you that are still keeping me company, Oroluwal is still on. Olalekan Adejimin is on. Imem Idriso. I have Joshua. I have Ijoma. I also have, yes, that's what I said, Leko. I still have Oluchi. I have Oluwatosin. Okay, I have Ramoni. I have Phillips. I have Victoria. All right. So in our next class, we are going to solve a complete question using the tool. I believe, of course, we are going to solve for shadow price. There's a shadow price in the let me even see the question. Let me share. Let me share the golden book. Let me share the golden book. Where are you? Okay. Let me see. Ah. Okay. Okay. Yeah. If you go to your this thing, if you go to the golden book, you see I use the two method, both increase the number of constraints, but that's not how. I want to show you the next question that we are going to solve. The question tested by the last question tested by ICANN, that was in 2023, was it May or November that? That was the last question on linear programming. I want to show you, I want to confirm if there's a shadow price in the, I think that was, examiner asked you to do shadow price. Well, let me confirm. So that in our next class, that's what we are going to do. Please go ahead and practice as many questions as possible. Go and practice as many questions as possible. All right? You may be lucky, you may be fortunate. This illustration number, which one again? One of the illustration in the material, this biggie. I can tested it twice. The question was tested twice. Of course, they can't repeat it again. I want to show you, not this one. Where's the question now? Have I passed it? Don't waste my time. This is it. This illustration number 8 here is the next one we are going to solve. This is the last question tested. I want to see whether I have shadow price there. Yes. You are asked to determine, you have to explain the concept and significance of dual price. Dual price is the same thing as shadow price. So calculate the dual price. All right. So in our next class, this is the question that we are going to solve. All right. That's the question we will solve. So let me know if you have any question for me, guys, so that I can release you. Any question? All right. So in the absence of no further question, please take your time, master the procedures, don't accumulate your notes. And if I ask you now, if you guys have studied the optimal product mix that we did in our last two classes, I'm very sure majority of you might not have, gone through the questions that we solve again and all those concepts that we discussed. Please, time is going. For each day that pass, you are getting closer to the D-Day. Your exam is getting nearer. Please, I beg of you, time is going. Take it very seriously. Your money is already counting. Hey, your money for exam, money for lecture, everything is already counting. Please, I beg of you, make it worth it. Because the reward for your labor, the reward for all your effort will be your success on the day when your result is released. Because if there's any reference, that means you have to come back again so you have to rewrite the ICANN exam. That means all the efforts for attending classes, all the effort to read will be wasted. That will never be your portion. All right? Please take it very seriously. As you are approaching the D-Day, you have to double your efforts. You have to double your effort, knowing fully well that you are not coming back to write that paper again, because this is going to be once and for all. You are not coming back to it. Therefore, you have to double your effort. In fact, when sleep is coming, go and wash your face, or you perform ablution. For those of you that are Muslim, perform ablution, or you go and shower, then you refresh yourself, continue again, because something is chasing you. You are chasing something, you are chasing ICANN qualification, and then something is chasing you. That your success that you want to achieve. It will not come. We can only pray that God will make it easy for you, yes. But on that day of the exam, we can't say because should make it easy for ICANN will not give 1 + 1 is equal to 2. No, it doesn't work like that. It doesn't work like for you to become a professional. You have to do the right thing. And that's why we are encouraging you. Go all out, expose yourself. All the topics we have covered so far, go to ICANN Pathfinder question and answers and begin to practice them, because that is your responsibility. You need to practice. While you are in the class, there is no way your lecturer will teach you or will solve the entire questions. No way lecturer will solve the entire questions in the Pathfinder. They can only give you a guide, all right? And that's what we are doing, all right? Please go ahead, go and practice as many questions as possible. Make your money count, make your effort count, so that by the time when you clear all your papers and you move to the final level, then you have to buga. When you, when you get to professional level, you have to buga. I'm now a professional student. This is the final stage. I want to qualify this year. So please, guys, you can do this. It's not difficult. ICANN exam is not difficult at all. It's all about you. We've been telling you this all this month. We'll be telling you this. ICANN is not difficult. It's all about you. So that's why you have to develop that growth mindset, that this exam that you want to write is once and for all. I'm not coming back to it again. I want to clear all my papers so that I can move to professional level come July 2026, so that by November, by December, when my result is released, then I will end my qualification, because once your result is released, you become a qualified accountant. Then if you have the required or requisite years of experience, then you can go back. You can go to in May, you go and receive your certificates. That's it. May 2027, you go and collect your certificate if you have the required working experience, okay? Which is 36 months. You go and collect your certificate. I've ended my ICANN journey, and that's it. You then begin to buga anywhere you see your name. Anybody sees your name. Oh, Olalekan, ACA, BSc, BRT, APC, whatever your qualification, you put it there. All right, your designation. That's the essence of that. That shows that you are a professional. Guys, you should be looking at that. That is your aim. You want to end the ACA, and it has to be this 2026 by the grace of God. So give it whatever it will take you to achieve that. And I pray that God Almighty will make it easy for you. You will never struggle to pass your exam, because on that day, all the concept that you understand for all the subject that you want to write is what ICANN will test. Because when you see something you are familiar with on the day of your exam, it makes life sweet. It makes the exam so cheap. It makes the exam so ordinary to you. But some other people that doesn't have the knowledge of the concept, certainly they are going to struggle. You will never struggle by the grace of God. All right, guys, this is where we are going to stop tonight. I will see you next week by the grace of God, when we shall be completing the linear programming. Then I will introduce you to a brand new topic. So I mentioned to you last week that it's likely that we may like after we are done. After we are done with, let me see first, because like I said, I don't know what I will get back to you when we are going to be having risk and uncertainty. I will surely let you know. So I need to check the topic we are at FM before I can do that. Okay, guys. Good night. Bye bye to all of you. See you next week by the grace of God. All right. Good night.